So we're going to take some time to talk about the final exam. Kind of outline what you need to do to prepare for the final exam, what topics you need to study, which is, of course, all of them. I'm not always very helpful in narrowing down your topics, but I try to jog your memory on what we did, right? So the final exam only covers lessons 7 through 12, right? You don't have to worry about lessons 1 through 6, except for the fact that some of lessons 7 through 12, particularly 7, 8, and 9, depended on lessons 1 through 6 a little bit, although the logic stuff was kind of its own little baby. You did a lot of conditional probability in lessons. Let's see, lesson 8 had some conditional probability, and it used the multiplication principle, et cetera, et cetera. Lesson 7 used the multiplication principle. And lesson 9 uses, it's mostly its own thing, right? It's kind of an isolated lesson. But there's 20 questions, just like the midterm. 20 questions, and you're allowed scratch paper, a calculator, handheld calculator, writing utensil, and the formula sheet. You can find the formula sheet in the files section in Canvas. I'll try to send it around to you the week before the final, and so you'll have that with you. Generally, you want to print that out on paper and have it with you. So there's that. Just like the midterm, there's kind of the midterm focused on the earlier lesson 1 and lesson 2 quite a bit. The final exam has a focus also. The final exam focuses more on, so about 2/3 of the final is on the last 3 lessons. The logic, right? Particularly lessons 10 and 11. There's some 12 stuff also, but more particularly lessons 10 and 11, because there was a lot of variety to the things that we did. And just like with the midterm exam, if you did a lot of things, if I want to include all those things on the final exam, then I have to ask a lot of questions. And we did a lot of different things in lessons 10 and 11, more 10 than 11, but both translations and truth tables and equivalent propositions and negation of propositions and all these different things that we're doing. So if I want to ask some of all of these, then we're going to have more questions from those sections. So probably 2/3 of the final exam is on the last 3 lessons, and more so for lesson 10 and 11 than lesson 12. But having said that, I get a lot of people that kind of ignore lessons 7, 8, and 9, thinking they're going to remember them, but there's definitely, you won't. You need to review those too. You need to spend time on everything. Okay? So let's go back. Lesson 7. Permutations. Right? So in lesson 7, remember, a permutation is an arrangement or an ordering. So the questions in lesson 7 were all about, maybe a section, this is section 8.4, I believe. me just make sure. I knew I should have gone back to chapter 8. Yes, 8.4, an arrangement or an ordering. Remember that repetition was not allowed if it's a permutation. If you had repetition, you had to use the multiplication principle. And there were a large variety of questions that we asked from this section. I mean, when you go back to the homeworks in the book and the quiz questions, you'll see all the different things that we did. So let me just throw out maybe a question or two. So how many 5-letter codes are possible? Right? So the question there, of course, is repetition allowed or not? So if repetition is not allowed, that is your basic permutation, P of 26, 5, which is the same thing. You can do this using the multiplication principle also, which is the same thing as 26 times 25, times 24 times 23 times 22, 26, 5, 4, 3, 2. Yes, just those things. Or using the permutation key on your calculator, which hopefully you found at some point, 26 NPR 5, and that was 7, 8, 9, 3, 6, 0, 0. So 7 million, almost 8 million different 5-letter codes were possible if repetition is not allowed. On the other hand, if repetition is allowed, then it is 26 to the 5th power. 26 times 26 times 26 times 26. I think I was short of 26 there, but you know what I mean. And that one, 26 to the 5th power, is 1,188,1376. 11 million, almost 12 million different ways, different 5-letter codes when repetition is allowed, right? So you're allowing A, or A, B, B, C, or A, B, B, C, D, E, or whatever it happens to be, right? So there's your permutation right there, and this is an arrangement also, but it doesn't fit into the formula. And its arrangement order is important because it's code, and clearly with codes, ABC is different from BAC. Okay? So permutations. Combinations was a big jump, partly because there was more variety to the questions, but partly because they reintroduced the probabilities, and there weren't any probabilities in lesson 7. So combinations, this is lesson 8. And there was basic ones where it was just arrangements, but there was also things like you have 12 people, and 7 are men, and 5 are women, right? And you select 4 from the group. What is the probability that you get 2 women? Right? So this is a problem I talked about a number of times, and there's a number of examples. You've got the big group, right, of 12 people, and you got 7 men, and you got 5 women. And you're selecting from the big group, and what's the probability of getting a certain number of these and a certain number of these. First thing to understand is that if I have 2 women, then I have 2 men, because I selected 4, right? It's not magical that you don't have to worry about the men. You're selecting 4, so if there's 2 women, there's 2 men. And so this is got the women, and it has the men, and it has the total, and hopefully you remember how these went, right? And so I had 5 women to choose from, and I chose 2 of them. I had 7 men to choose from, and I chose 2 of them, and I had a total of 12 to choose from, and I chose 4, right? And I'm going through these fairly quickly because hopefully it's just jogging your memory, right? 5 choose 2, 7 choose 2, and 12 choose 4, and just for the heck of it, we'll get an answer for that one, right? So 5 NCR2 times 7 NCR2 divided by 12 NCR4, and that's 0.424. 0.424. Should be fairly likely because there's close to the same number as men as women, and you're splitting this evenly, so it should be fairly likely. So that was one type, and they came in a lot of different forms. We had bad refrigerators, we had zeros and ones in codes, we had all sorts of different things. That's a good possibility right there. A lot of people see this and they think, I didn't do anything like that in the homework in the book, but in reality, you have to identify the style of question, and you did a lot of those, and there were a lot of examples in the section also. So make sure you're understanding what style of questions are able to identify those. I don't know what else. Arrangements. There was just a lot of stuff here. Arrangements of non-distinct objects. I think my favorite was the Christmas lights. So you have a string of 15 Christmas lights. Now actually, you know what? Let's do this one because this one plays off the last one also. Let's do a code question. You have 0, 1, and 2, and you have 15 places. So you have to have 15-digit code, right? And in each one of those digits is either a 0, a 1, or a 2. And we talked about these, right? And so the point behind this is there's no distinction between the different zeros. You know, you have a certain number of zeros, you have a certain number of ones, and you have a certain number of twos, but they're not distinct. The zeros are not distinct from each other, and the ones are not distinct from each other, and the twos are not distinct from each other, right? And so how many codes have 5 zeros and 6 ones? in them. Once again, as I said with men and the women, if you have 5 zeros and 6 ones, that makes a total of 11, and so you have 4 twos also. That it certainly is understood, right? Well, so you can think of this as 15 different slots in which to put these. We're going to choose where to put the zeros, right? So I got 15 slots to choose from, and I'm going to choose 5 of them in which to put the zeros. This basically is the 3 subset version of the last question I did, right? And multiply the ones. Once I've chosen 5 places for my zeros, I only have 10 places left for the ones. 10, and I'm going to choose 6 of those to put the ones in. And then for the twos, I have 4 slots left, and I need to choose all 4 of those to put the twos in, right? So there was also, well, I'll give you the alternative here in a minute, but let's get an answer for this one. So how many different ways? Notice this is not a probability, it's a how many, so I'm not looking for a denominator. If I had looking for a denominator, then I would have done that as a probability. So 15 NCR 5 times 10 NCR 6 times, well, that one's just 1, so I won't do that multiplication. Times 1 doesn't change anything. 630, 630. 630,630 codes. Now, a different way to do that, we did 15 factorial, you might remember this formula, and then in the bottom we did the factorial for each one of these. I had 5 zeros, so that's 5 factorial. I had 6 ones, so that's 6 factorial, and I had 4 twos, so that's 4 factorial, right? And this also will be 630, 630, so that's another way to do that problem. Once again, a lot of variety to the questions in lesson 8. I can't go through every single one of them. You need to review that. That's part of, what you need to do to prepare for the final exam, right? So there's that. Lesson 9, we only did one thing in lesson 9, the binomial model. Now, because this is a situation where you've got, some people think of this as a set and you have 2 different possibilities. A lot of people mix that up with the men and women example I just did. The difference between the binomial model and the men and women example that I did just a few minutes ago is that with the binomial, the probability doesn't change, right? And with that, when you have a small set with only 12 in it, I think I had 7 men and 5 women, when you choose somebody, you change that probability. There's only 11 left, right? The binomial, the probability never changes. So you're given a probability, you have a fixed probability each time. And that probability does not change from time to time. So, for example, the probability someone owns has a Mac, an Apple, some kind of an Apple computer. I've noticed that my students have a lot of them own Apples, so they got an Apple for graduation or something like that. So the probability that somebody owns an Apple computer, P might be 0.78. It's fairly probable that an undergraduate student owns an Apple, right? 0.78. That remains fixed. That doesn't change from person to person. That's a fixed probability, and so clearly this is a binomial, right? So if you have 12 people, what is the probability that 10 own apples? Some kind of apple product, right? And this is a binomial because that remains fixed. And you have to repeat that experiment 12 times. What's the probability of 10 successes? So the probability of 10 successes, right, is going to be C of 12 comma 10, the number of ways to choose the 10 people out of the 12 that are going to own the apple, right, times 0.78, the probability of success to the 10th power, probability of success, I need 10 successes, probability of failure, 1 minus 0.78 is 0.22, and how many failures am I going to have? I'm going to have 2 failures, right? So, binomial. Recognition is the biggest problem with the binomial question or questions on the final. I think there's probably 2 of them. I try to get 2 from every lesson. People don't recognize it as a binomial, right? So you really need to make sure you're spotting the approach to take on the problem. So this is 12 NCR 10, and then some people have a hard time executing, even though it went well when they did it on the homework and on the quizzes. When it comes to the final, they didn't practice enough. They think, oh, I'm going to remember how to do that, and then you don't, right? So make sure you're working on recognition and practicing execution. So that is 0.266. And the next digit is 2, so it remains 0.266. That's the probability of 10 successes. So once again, execution shouldn't be a problem, sometimes is, but recognition. And it's hard sometimes when you think, oh, you know, these are really straightforward, but then when you're looking at that final, number one, the problems are all, you know, thrown at you at the same time. I don't mix up the order on purpose a lot, but, you know, you got a lot of problems coming at you at once. Identifying which approach to take is key, and so that's one thing that you need to study. You can't just assume that you're going to recognize the problem. It's something to study, right? Now, the one other thing that we did in the binomial is we also did the expected value of a binomial. Right? So E, that expected value, is N times P. The number of trials times the probability of success each time. So in our case, E is equal to 12 times 0.78. I have success, i.e. somebody owns an apple 78% of the time. I'm going to do that 12 times. How many successes would I expect? Oops. 9.36 is the expected number of successes out of your 12 attempts. Right? That's your binomial. Okay. Both the basic formula on your formula sheet, I believe the expected value is also on your formula sheet. So look for that and don't miss it when it's there on the final exam. Recognition is key. That's the thing that people miss on this one. Okay. Then we moved into the logic. So lesson 10. Did a bunch of stuff in lesson 10. We got introduced to our connectives. We talked about propositions or non-propositions. Can you identify when something's a proposition, when it's not a proposition? You know, these quiz questions will probably help you with this. translations, right? Translations are also key to doing your proofs. Translations are important. Negation, both propositions with quantifiers and using De Morgan's. We had those two different types of negation that we spent some time on in lesson 10. We started doing truth tables in lesson 10. We use truth tables to prove that two propositions are equivalent. And these are some of the, I talked about how there's a lot of different I think I said lesson 10 and wrote 12. There's a lot of different things that we did with the logic. These are some of those lots of different things. It's lesson 9 we did one thing. Lesson 10 are all of a sudden have propositions, not propositions, translates both directions, negations of quantifiers and De Morgan's, 2 different negation questions possibly. There'll be a couple of truth table questions. Proving that propositions are equivalent, that's another truth table questions. Truth tables are particularly important for the final exam. If you're not comfortable doing truth tables, then it's going to be a tough final for you. So because they get used in a lot of different things. So we're looking at 6 or 7 different topics here, 6 or 7 different questions on the final exam. So a lot of the final exam is these kind of introductory things to logic, and they happened in lesson 10 and lesson 11. I'm not going to go through examples for those because that should be fairly fresh in your mind. Let's see. I can't remember whether tautologies came in lesson 10 or lesson 11, but we'll pretend they're in lesson 11. Tautologies, that's another question that uses truth tables. If that truth table has all T's in that final column, then it's a tautology. We had the converse, inverse, contrapositive. You, of course, want to review those, remember which is which, because I will be asking you to give me the converse, inverse, and contrapositive of statements. Lesson 11, you had more truth tables. And equivalence and stuff like that. So just kind of more of the same, but the converse, inverse, and contrapositive got added in lesson 11. Translations. Anything I forgot from my lesson 10 stuff that really I don't remember. I think of lesson 10 and 11 as just kind of overlapping. Yeah. Okay. And then finally, lesson 12. And the questions in lesson 12 are relatively similar to the quiz questions in terms of I can ask you pieces, but I can't ask you to complete an entire proof. So lesson 12, I can ask you whether an argument is valid or invalid, and once again, of course, the easiest way to do that is to do the translation to see if it fits into one of our valid forms or can be proven, or if it's an invalid argument. The questions, of course, have to be more of the true-false or multiple choice questions in terms of the proofs. Did you use a contrapositive? Did you use the law of detachment? Some of the questions that I give you are a little more general. How does an indirect proof work, right? Or how does a direct proof work? So I try to mix those in with individual questions about that particular proof. So you'll have some of that, did you use the law of contrapositive, yes or no? If you use an indirect proof, did you have to use the law of detachment, or how does that indirect proof work? And I don't want to get any real specifics about that, but if you understand how those proofs work, then they're going to go fairly well. So look through those quiz questions, be prepared for ones that are similar to the lesson 12 quiz questions, and understand how those proofs come together. On your scratch paper, make sure that if I'm asking you to look at an indirect proof, give me that indirect proof, right? Because maybe if you did it using when you did your indirect proof, but you didn't realize you used it and got it wrong on the test question, even though you had it right on your work on the scratch paper, then I can give you almost full credit. I can't give you full credit if you mark the wrong answer, you generally, unless, So there's that. So that's the final exam. And make sure you don't leave the earlier lessons alone too much. People have a tendency to focus more on lesson 12 because that's the tough stuff and that's what's fresh in your mind. I would start by reviewing lessons 7, 8, 9. Make sure you're comfortable doing those problems. Make sure you're comfortable identifying them. Make sure you're totally comfortable with your truth tables, your translations, your equivalents, and then take the time to review lesson 12. If it really didn't go well, you're going to do the best you can. If lesson 12 went fairly well, then you're going to brush up on it a little bit. So that's what I have. Good luck on the test, on the final exam, everybody. And I will get them graded as soon as possible, and you'll have your scores.